welcome to lesson 5 in our course pertaining to basic or basics in program or basics programming techniques. So let's go ahead and look at the course outline for this particular lesson. So in this course outline, we have control structures. We're going to look at control structures where we'll be looking at sequential statements, selection or decision or conditional statements. From there, we proceed and look at single if statement, if else statement, and then relational, logical, and then equality operators. So basically, this is what we shall be looking at in this particular lesson. So let's go ahead and look at objectives. So by the end of the lessons, learners will be able to, one, explain the concept of sequential statements, selection, decision, conditional statements. Two, differentiate between sequential statements, selection, decision, conditional statements as well. And then three, use single if statements and if else statement in writing simple programs or in making decisions in our programs. And finally, be able to use relational, logical, and then equality operators in writing simple programs. So basically, that is what we shall be looking at. Or these is our lesson objectives. I entreat each and everyone to pay attention in this lesson and try not to skip the video in any case, because at the end of the lesson, we'll be having a very trickish but straightforward assignment for us to build our confidence as well as try our way of thinking. So let's dive right into it. So let's talk of sequential structure. We talk of sequential structure. Programs we shall be writing or any other programmer will be writing. As a programmer, you should be able to see what another programmer writes and be able to tell whether this belongs to sequential structures or sequential type of program. This is decision. This is iterative, as we saw in our previous lessons, or whichever. You should be able to tell the kind of program it is. So that is one of the skills or skill of a good programmer. Now, what is a sequential structure? Or the sequential structure, what is it made up of? A sequential structure is made up of a series of consecutive statements executed in order in which they appear. For example, the statement we write, programming is about writing statements, and then these statements are executed line by line. A situation where we have a program and each and every statement is executed line by line without a decision making at any point in the statement, it is called sequential structure, that type of statement. This is a typical example. I'm going over the definition again. A sequential structure is made up of a series of consecutive statements. The statements are in consecutive, one after the other. And they are executed in order which they appear. In order which they appear means the first one is executed and then followed by the second one, third one, and fourth one in that order until the last one. For example, let's look at one of the typical example of what sequential structure type of statement or type of program. Here we have the enter a number. So the user goes ahead and then do what? Enter the first number. Enter operator. Here we are being specific and we are telling the user to enter this type of operator, which is what? The plus. Enter second number. Then the user does that by entering the second number. And finally, it will process or compute and display the result. So you see that it's very straightforward, sequential, no curve, no bend anywhere. It's like we talked of this in our previous lesson. Yes, so this is a typical example of what? Sequential structure. They are executed line by line in which they follow. So that is that. Now let's look at the decision or selection type of structures or type of program. In our daily activities, we make countless decisions every day as human beings, right? These decisions help us to get work done and improve our lives. For example, I'm saying I can make a decision and I can say that after recording this video, I will have to pass it over to what? Our editor. Then he does the editing. If he is not around, then I'll have to look for another editor and do that. If he is not around, then I will have to look for another person. You see, these are some of the decisions we make to get our jobs done. So you can see that I've just made some simple decisions here based on the conditions in which I find myself. I have the who designs or maybe who edits the videos for us. If he is not there, then I'll have to look for what alternative. If he is not there too, then I'll have to. So these are the decisions we make. So let's look at some of the examples. I say examples of decisions we make on a daily basis are plentiful. They are many. They are many, countless. Some examples are as follows. Say, if you are hungry, then order for a meal. It's a decision you make. If you are hungry, you order for a meal. If it is the end of the month, then pay the bills. We all know what we do at the end of the month. We pay bills, right? These are all decisions. If the alarm clock rings, then get up. So it's a decision. If it rings, you get up. If you have decided to do that, it's a decision you've made. If you are driving and it's nighttime or it's raining, then turn on the headlights. So it's a decision. So these are some of the decisions we make day in, day out. You can even state more of that. Now, let's look at the decision selection or the decision or selection type of a program. So one of a computer's characteristic qualities is to what? Is its ability to make decisions. Yes, the computer's ability to what? Make decisions is one of its powerful what? Characteristics. And we are the same people doing what? We are the same people programming the computer to make decisions. Very soon you see that. Yes, that is to select one of several alternatives, groups of what? Statement based on a condition. So based on the conditions of our program, we give the computer statement and directions. If this is this, then do this for us. If this is not that, then leave that one and do this. The computer follows the same thing and then do that for us. So basically, that's that. So these groups of statements together with the conditions that determines which of them is to be executed make up what? A selection or decision control structure. A program where we have at a point in time we decide what to do and what not to do forms what? The selection or decision type of what? Program. If you see a program in which there is a decision making, that program or the program is termed as what? The selection or decision control structure type of what? Program. Within those programs, at a point in time, we make decisions there. We'll be seeing example, a typical example. So as a selection or a selection structure consists of what? Test condition. In this type of programs where we have selection or decision, there is a test condition together with what? One or more groups of what? Blocks of statement. After that particular test condition, we'll see what a test condition is, and then the blocks of statements after the test conditions. And very soon we'll see the ones that will be executed and the ones that will be skipped based on the decisions or the conditions at hand. We'll be seeing that in a couple of minutes. So a selection structure consists of what? Test condition together with what? One or more groups or blocks of what? Statement. Let's look at that. Now let's look at this type of selection structures. The first one we have here is what? A single alternative. You know, in our examination questions where we have multiple alternatives we give to our questions, like section A, where we have alternative A to D, then the student choose among and then choose the right one, right? So in programming, we have the same thing here. But in this case, in it's not in all programs that we have multiple alternatives. There are some we have just one, only one alternative, depending upon the type of program you are writing. There are some you need only two, depending upon the type of program you are writing. There are some you need more than even 5 or 10 alternatives. Then the program decides which is to be executed and skipping which. Very good. So let's look at the first one, which is what? A single alternative. This one, it has only one alternative, which is also called what? The if statement. I just love this type of statement. It's one of the magical tools in programming, if statement. It helps you to make decisions in your program. Very soon we'll see all that. So what? A single alternative. And this single alternative is also called what? The if statement. The if statement. This structure contains only a single block of what? Statements. If the test condition is met, that is, if it is true, the statements are executed. If the test condition is not met, which is false, the statements are what? Skipped. Based on the condition that you will be given to what? Your program. If the test condition is met, which is true, then the code below is going to be what? Executed. If it is false, then it will skip it and then end the program. Let's look at a typical example here. Here we say enter something, right? So let's say maybe you enter a number here. And we say if the number is odd, display here and say what? Then this is what we term as what? The test condition. And this is the condition sign, right? We talk of this when we're dealing with the symbols of flowchart. So you know what this is. This is the test condition, and this is what? The statements. If this test condition or the test condition here is true or is yes, you execute this block. If it is no, you do nothing here, but you only come here and exit. If it is yes, you execute this block and exit at the end of the day. Because every program has starting and ending. You execute and you end. If it is no, then you do nothing. You only come and then exit because you have only one alternative. That is why it is termed as what? Single alternative or if statement. If the number here is odd, display here and say the number is odd. If the number here is not odd, you don't do anything. You don't display anything. You skip this block and then you go here and then exit because you are only looking for what? Odd number to be able to execute this block. If you didn't get the odd number here in the condition here, if the condition here is not odd, then you don't do anything. You skip this block, then you only come, you just pass here, and then you exit. So that is all. So this is a typical example of what? Single alternative. Let's look at maybe another example is here. Okay. Yes, this is another example of what? A single alternative or the if statement. This is a simple program which we're going to look. So let's see. The first statement says what? Enter a number. So the user enters a number. If the number is greater than 6, display and say number is greater than 6, and then exit. So what is going to happen here is this. This is just a statement, like an instruction. So enter a number. So you input a number, right? So this is the test condition here. This is what we call the test condition. If statement. This is the single alternative. If statement. This is the test condition. And this is the what? The statement that is going to be executed if this test condition is true. How will this test condition be true? This test condition will be true if the number here is greater than 6. Then it means the test condition here is true. And for that matter, the block of code or the statement under it will be executed. If there is another statement, it will be executed. If there is another one, it will be executed. But if this test condition is false, it means the number here, that the number the user enters is what? Less than 6. And for that matter, not this block, this statement will be skipped and then the program will exit. Because we didn't take care of what? A situation if the number is less than 6, then that one will say what? Do something else. No, we didn't take, we are not, we haven't gotten to that. We'll get there very soon. This one we have only one alternative, and that is the number the user is going to enter should be greater than what? 6 before you display this. If the number is less or any other thing, don't do anything. Just skip this and come and exit. That is all. So this is a typical example of what? Single alternative. We have only one alternative. Let's proceed. Now, let's look at the second one, which we call the dual alternative or if-else statement. Anytime you hear if-else statement, it is an example of what? A dual alternative type of what? Program. So this structure contains 2 blocks of statement. It has these 2 alternatives. And under each and every alternative, there are 2 test conditions. Any of them that is met, the block of code or the statement under it will be executed, and then the rest will be skipped. So that is that. Let's look at how that happened. If the test condition is met, which is true, the first block is executed and the program skips over the second block. If the test condition is not met, which is false, the first block of what? Statement is skipped, and then the second block is what? Executed. Let's look at that here. Enter a number. Let's say we try to enter a number here. Maybe we are checking the age of someone. Say enter age. If the age is less than what? 18. If the age is less than 18, or is the age less than 18? If yes, then do this and don't do anything here. Else, if the age is what? Is the age I want to give the age range. It should be what? Greater than 18. Yeah, I want to check it that way. Greater than 18. It should be greater or equal to 18. Good. It should be greater or equal to 18. That means you are qualified to do something, as we already know. If the age here, if the age the user enters here is greater or equal to 18, then, so the question here is going to be something like, is age greater or equal to 18? If yes, display and say, you are qualified to watch this type of movie. If no, so that is when the else come here. We will see the pseudocode for that. This is the flowchart. If no, then tell them that you are not qualified to watch the movie. If no means that the age here is either greater or equal to 18. It means the age here is less than 18. So it means you are not qualified to watch that movie. So here we have two alternatives. If I put 17 here, this block will be skipped. And then this one will be executed. Why? Because the age is what? Less than 18. So it will skip the block here and then execute this one and then exit. If I put 18, 19, 20 and above, then this one will be skipped and then this one will be executed. So you can see that in this particular program, we have two alternatives. That is why it is termed as what? Dual alternative. Two. If this is not executed, this will be executed based on the condition here. I'm repeating this over again. If I decide to put 17, 16, 15 or whatever here, this block will be skipped and this one will be executed and the program will exit. If I put 18, 19, 20 and above, which means that the age is what? Greater or equal to 18, then this one will be executed and this one will be skipped. And then the program after execution, this one will also exit. So this is what we term as what? The dual alternative or the if-else statement. If this, do that. Else, do this. So let's see how the pseudocode looks like. Good. Another example of dual alternative written in pseudocode. This is just a simple example. Say enter a number, so you enter a number. So we're using the same example as the single alternative so that you can understand better. If number is greater than 6, display number is what? Greater than 6. So you have the first alternative here. Else, you have the second alternative. Else means the number here is what? Less than what? 6. So display and tell them that the number is what? Less than 6. Unlike the single alternative, which we have only one alternative here. And if this is not met, the program exits and there is no any block here. So let's see the block that is executed and the one that is skipped based on the condition. If the user enters a number and the number is greater than 6, this is the test condition and this is the statement under it. I repeat, this is the test condition. We are testing it here. If the condition here is met, this is executed. If it's not met, this block will be skipped and check on this one. It means this one is met and this one will be executed. If this one is met, this one will be executed and then it will skip this one and exit. So that is how it is. Enter a number. If I enter 1, it means it's less than 6. So this one will be skipped and this one will be executed and tell me number is less than 6. If I enter 7, it means the condition here is what? Met. So this one will be executed and tell me number is what? Greater than 6. So basically that is that. If number is greater than 6, display number is greater than 6. Else means anything less than 6. Display and tell them that the number is less than 6 and then exit. So basically this is an example of what the dual alternative, or which is also called the if-else statement. Let's proceed. Now we have the third one, which is called the multiple alternative. With this one, you have a lot of decisions to make, a lot of alternatives with a lot of test conditions based on the type of program you are writing. Good. The multiple alternative structure contains more than 2 blocks of statements. Yes, it contains more than 2 blocks of statements. It can be many, right? The program is written so that when the test condition is met, the block of statement that goes with that test condition is executed, and all other blocks are what skipped. Since we have a lot of test condition and their respective statement, the one that will be executed is the one that its test condition will be met. Let's see the example. This example is written in Flowchart. So multiple alternatives. So we have 1, 2, 3 alternatives. So you can see that it's more than 2, right? That makes it multiple. It can be 3, 4, 5, 6, 7. If it is 2, it is dual. If it is 1, it is single. If it is more than 2, that is 3 and above, it becomes multiple alternative type of program. That is that. So this is a multiple type, right? So you enter. To enter something here. What do we enter here? It's a condition we're going to take here. Maybe enter operator here. Let's say operator. So we are going to use the mathematical operators, either the plus or the minus. These two. We need these two. If the operator here is plus, then come here and then do what? Add, maybe enter number 1 and number 2. The user enters a lot of things here. Enter number 1, then you enter number 1. Then you enter operator, then you enter operator, then it's taken. Then enter number 2, then you enter number 2. Now we're going to make decision with these 3 inputs we've taken. We've taken the first number, the operator, and then what? The third number. The second number. So we're going to make decision with them. If the operator the user enters in addition to the 2 numbers here is what? Is a plus, then sum, add the first number and second number here. Do that. Give us the sum of what? The first number and second number. But if the operator the person enters in addition to what? The 2 numbers here is minus, that is subtraction, then subtract the second number from what? The first number, and do that here. Else, if the user enters anything aside these 2 operators, maybe the person decides to enter what? Multiplication, or maybe any other, then we would want to, okay, let's say if it is multiplication, then don't do anything here, multiply the 2 numbers here, and then display the results here as well. I'm sure you are getting the example here. Let me go over again. We need 3 operators. So it's like a program we are writing, like a basic calculator, right? Written in the flowchart, where we need 2 numbers and then any of the 3 operators. That is either plus, minus, or multiplication. So these are the inputs we shall be taking. Prompt the user to enter the first number, the user enters the first number. You prompt the user to enter operator, then the user enters another operator. User enters operator. You prompt the user to enter the second number, the user does that. Now you go ahead and make decision with these 3 inputs. We don't know the operator the user is going to enter here, right? So we make decision from there. If the user enters what? Plus, then add the 2 numbers here and give us the results. And then ignore this and ignore this. It means these 2 are skipped because the condition here is met for this one. So this block will be executed. If the user enters minus, which is subtraction in addition to the 2 numbers, then don't do anything with addition. Skip this, come and subtract the second number from the first number here and display the results here. It means we skip this and skip this. So it means the test condition here, which is subtraction, is met, and for that matter, each block of code is here, it will be executed. But if the user enters multiplication sign in addition to the 2 numbers, ignore the addition, ignore the subtraction, come and then multiply the 2 numbers here and do what? Display the results here. You come and exit. So after executing this one, you come and exit. After executing this one, you pass and come and exit. At the end of every program, it must end, right? So that is how it should be. So basically, this is a typical example of what? Multiple type of what? Statements. So we can use this to make a lot of decisions. Let's continue. Let's look at a typical example here. This is a typical example of a simple calculator written in pseudocode. So another example of what? Multiple alternative is similar to the one we just saw in the flowchart. Here we prompt the user to enter first number. So with this type of calculator, we are going to make decision based on the operator the user enters. And here we're going to take all the 4 operators. That is what? The plus, the minus, the multiplication, and then what? The division. We're going to look at all that. So you want to write a program. The user enters the first number, enters the operator, enters the second number. Then you make decision with them. But in this case, we don't know the type of operator the user is going to enter, right? So we have to cater for that. As a programmer, you have to cater for all this. So enter first number, the user enters the first number. Enter operator, which we don't know the one the user will enter an operator, which we might not even know. Then enter the second number, then the user enter the second number. Now we're going to make decisions. So this is a test condition. If statement is here, if statement. If operator equal, we are comparing. So this is a comparison operator. You should know this by now. If operator equal to plus, what we're talking about is if the operator the user enters here alongside the 2 numbers is a plus sign, then it means this condition is met. So execute this block. And how do you execute it? Add the first number, that is first number plus second number, and then display results. So you execute this. It means this condition is met. What if this condition is not met? Which means the sign or the operator the user enters here is not plus. It means we are going to skip this one, and then we'll skip its blocks of statements, right? So we're going to check again. If the operator the user enters is what? If operator, if this is not met, we want to cater for the second decision. Else, if operator is equal to what? Minus, which is subtraction. This means it's no addition. So we are skipping this one, and then we are checking here. If it is equal to what? Subtraction, then the result is equal to what? First number. So subtract second number from what? First number and display results. So a situation where the sign is not addition sign, we skip this one, and then if it is subtraction, it means this test condition is met and 8 blocks of statement will be executed, and the rest together with the top one will also be skipped. Now we check what if the operator is neither plus nor minus. Then we check and see, is it multiplication? Else, if the operator is what? Multiplication, then we do what? We multiply the two numbers and display the results. It means we are going to ignore the subtraction, ignore the addition, because the operator is not what? Any of the two. It's rather multiplication. So we attend to that one. It means that test condition is met, and we execute the blocks of code under it. And finally, we look at the fourth operator, which is what? Division. What if the user enters division? So we're going to skip the addition and its block, skip the subtraction, skip the multiplication with their respective statements, and we come and check on what? Division. So what we do is that we divide the two numbers and then display the results. So what if the user enters anything else aside these four operators? We want to catch an error here. So we say else, whatever you enter aside these four operations, display invalid operator. Tell the user that you've entered an invalid operator. So the user knows that, hey, what I've entered is not compatible with the program. It's not part of the operators. So I will have to go back and check and enter the right operator to be able to execute the program, to make the program run successfully. So basically that is that. So this is the test condition, this is its block. If this test condition is met, this is executed. Else, if this one is met, this is executed. Else, if this one is met, this is executed. So if one is met and is executed, the rest are skipped. I'm sure you understand this right now. So that is that. Let's look at another one we call a single if statement, and how it's written in pseudocode generally, how it's generally accepted and it's written in pseudocode. So the simplest type of word selection structure is the if statement, or the single alternative, the single one we just talked about. And we have a way of writing it in pseudocode, which we'll be looking at shortly. Now, the test condition is an expression that is either true or false, just as we saw. If it is true, we know what it means. If it is false, we know what it means. And at the time of execution. In pseudocode, the beginning of a selection structure is with what? An if statement. Where you want to test a condition, we start with what? The if statement. And the end of the structure is indicated by what? End if. This means that particular structure has ended. So we jump out of that one and go to another structure. Let's look at the example here. Now, example says determine whether to take an umbrella and a jacket for the day in pseudocode. So first of all, we want to check whether the user should take an umbrella and a jacket during the day. And under what condition do you take a jacket and then umbrella? So let's see that. The first line of code says what? Start. This is written in pseudocode. Don't forget. Start. Then the 2 says if it's raining, or if raining, then take an umbrella, take a jacket. You know how we protect ourselves when it's raining using these two items, right? And then you end if. Anytime you start with if, and then you bring the test condition, and then you bring the statement that should be executed when that test condition is met, you bring end if to terminate that particular one. That means if this is executed and this is executed, just end it and jump out of it, and the program ends. So that is what we are talking about here. So this is how it's written in pseudocode, which is generally accepted. So it's if raining, then do something. Take an umbrella, take a jacket. It can be only this one. Only take an umbrella and end if, and then end the program. What it means is that if we have another test condition, that one too will check on it, and then after that test condition is met, 8 blocks of code will be executed, and then it will end if. So basically that is that. The test condition starts with if statement, and then it ends with what? End if. So that is that. And then finally the program ends. Let's look at the flow chart for the example I've just shown you. It starts, and you ask, is it raining? If raining, that is yes. Take an umbrella, take a jacket. If it's not raining, don't do anything. Just exit the program. That is all. So I hope you understand this. Now let's look at the if-else statement. Say the if-else or the dual alternative structure has the general form, just as we look at how the single alternative look like. The dual also look like this. if test condition here is met, you don't know what the test condition is, what the test condition is by now. If test condition is true, then execute the statement, execute the statement. Else, leave this statement, it means this test condition is not true. So leave this one and come and execute this one and execute this one and end if. So if you start with if, you end with what? End if. That is how programs are written, generally in pseudocode, which is accepted. So if test condition is met, then display this, execute the statement, execute the statement. Else, if this is not met, and you leave this, you skip this one, you come and execute this one, and then you end if. So basically, that is that. Now let's look at the if else statement once again. Another example. So if we want to check if a user is 18 and above or below 18 years of age in pseudocode. So this is a program that we can use to check if the user is above 18 years or above or is below 18 years of age. It's written in pseudocode. One, start. We declare age as what? An integer, and you know why. So we prompt the user to enter age, then we input the age. So here we're going to make a decision. If age is greater or equal to 18, it means you are 18 and above, then display qualified. It means you have qualified. Else, display disqualified. Display disqualified, and then you end with what? And if means the program is done, and then you end it here. So you see how decisions are made. So this is how you program the computer to do. So basically, that is, I say, declare age as an integer. So you do that. So the user enters the age, and the age is entered, and then we input it. So you make decision with it. So this is a test condition, and this is the block. If age is greater than or equal to 18, it means 18 and above. We tell the person you are qualified. Else, which means it's below 18, we tell the person you are disqualified, and then end if, and then you end the program. Now, here is how the structure works. More explanation on how the structure works. If the test condition is true, then a block of statement between the if statement and then the word else, that is the then clause, is executed. This is what they are talking about. If this test condition is true, then the block here, which is between the if statement and then the else if, is executed. This is executed. Else, if it's not executed, this one will be skipped, and then to come and check this one. If this is true, then this one will be executed. So that is that. So if the test condition is false, then the block of statement between else and then end if, or that is the else clause, is executed. It will skip the first one and then execute the second one, as you saw. In either of the cases, execution proceeds to the program statement following end if. So after executing the program, you have to end by saying end if before you end the program naturally. Now let's look at another sample program here. It's a program to determine if a number is even or odd. This is a simple program we can use to determine if a number is even or odd. So to do this, we need a statement that do the following. First, test the number with an if-else statement. If number is even, that is if we subtract. If the number we input here, we keep subtracting. This is the modulo sign. You remember, we keep subtracting 2, 2, 2 until we get 0. It means the number is what? Even. If we keep subtracting from the number and then what we get here is not 0, it means the number is what? Odd. Don't forget. Let's assume you put 4 here. 4 minus 2 is what? 2. 2 minus 2 is what? 0. It means the number is what? Even. Let's assume you put 6 here. 6 minus 2 is what? 4. 4 minus 2 is what? 2. 2 minus 2 is what? 0. It's even. So all even numbers after subtracting 2, 2, 2 till the last end, it will return 0 as the final answer, because at the point where we can't subtract anything again, it becomes even. But if after subtraction, you end up getting a particular number, that is maybe 1 or whatever, it means it's odd. Example, we put 3 here in the number. When we subtract 2 from 3, remaining what? 1. It means this is not, what do you call it? Even, rather is what? Odd. So basically, that is that. Let's see the program. The program is written in pseudocode. It starts. Declare number as integer. The number the user enters, we declare it as what? Integer. Right. Enter a number. So we prompt the user to what? Enter a number. Then we do what? We input the number. So we make decision here. If number modulus what? 2 equals 0. When the number you put here, if we keep subtracting 2 until we get to 0, then display and tell the user that the number is even. So if this test condition is met, this block is executed, and then this one is skipped, and then the program ends. But if this test condition is not met, it means this condition is what? It should be met, and for that matter, we display. If the number is not even, it should be odd. So we say else. If this is not true, then it means this should be true. So else display number is what? Odd. And then you end the program. So that is how this simple program is written. That is in the dual alternative type of program. So basically, that is that. Now, this is the flow chart showing what we just saw in the pseudocode. We declare the number as an integer. We input the number. We make decision here. Is number modulus equal 0? Or what we are trying to check here is the number even. If it is even, it means yes, display even. If it is no, display number is what? Odd. And the program. So that is that. Let's look at the if statement. That is the multiple alternative. So what? The if statement is a chain of statements that test in order until one is found to be true. With this one, we have a lot of statements, just as you saw in a simple calculator where we had all the 4 operators there. So this is a typical example of if statement type of program. So in an if structure, test will stop as soon as a condition is true and all other conditions is skipped. So in our previous program where we wrote a simple calculator, taking all the 4 operators and deciding the one and then execute it block, what is going to happen here is this. After entering the operator, if it determines that the operator is what? Addition, it will only come for the addition test condition and then execute it block and leave the subtraction, leave the multiplication, leave the division, and leave the rest. It will skip the rest. So that is what we are talking about. In an if-else structure, test will stop as soon as a condition is true. If it checks and it gets one of the operators, so it will only execute the blocks for that particular operators, and then the rest are skipped. So that is that. The if-else, if statement syntax. Let's look at how the syntax look like. The if test condition is true, then execute its statement, execute. Else, if this test condition is true, execute its statement, execute its statement. Else means if this is not met, then jump them, skip them, and come and execute this one. So basically, that is that. And if this is met, and if this condition is met, so this one and this one will be executed, and this one will be skipped. If this is met, this and this will be executed, and this and that will be skipped. If the last one is met, the last one will be executed, and then the second and top one will be what? Skipped. So this is a flow chart for that. Start, test condition here. Is it yes? If it's yes, this statement will be executed and the program will end. If it is no, then this one will be executed. So we check. Start, test condition. If it is yes, this is executed. If it is no, we check here again. If it is yes, we execute here. If it is no, we come and check here again. If it is yes, we execute the statement. If it is else, means if none of this is met, we will come and do by default. This one, we just come and execute this block and then we end the program. So that is that. Else means if maybe we are taking some operators and after taking the 4 operators, the user decides to enter a different operator, which is not part of our program. So we are trying to catch that. We say else, display and tell the user that you've entered the wrong operator. So else comes in there. So basically, that is that. Now let's see. Say example, determine if a user enter a positive, negative, or 0 in pseudocode. So this is a pseudocode, right? Say start. Declare number as integer. So we declare the number as what? Integer. So display enter a number. So the user enters a number, then we input the number. If number is greater than 0, then write number is what? Positive. Any number greater than 0 is positive. Else, if the number is what? Less than 0, write negative. If you are not greater than 0, then it should be less than what? 0. Else, then you should be a negative. Else, then it should be what? The number should be 0 itself. So the program goes like this. Start. Declare number as an integer. Display, enter a number. So the user inputs a number. If they will make decision with the number. If number greater than 0, then tell them that it's positive. This means if this test condition is met, this block of code is executed. Else, if number is less than 0, then it means what? Right. The number is what? Negative. It means tell them that the number is negative. Else means anything aside this means display number is what? 0. Tell them that the number if entered is actually 0. It's neither negative nor positive, but rather it's 0. So we tell them that, and then end if, because we start with if, so we come with end if, and then we end the program. So basically, that is that. Now let's look at relational operators. Relational operators. Excuse me. Thanks. Just water break. Let's look at relational operators. Decision making involves testing a condition to help construct these conditions. We use logical operators. there are there are six standard relational operators. So these operators we have here are the six standard relational operators we have in programming. Now, basically, we use them in our decision making, and they are very, very, very helpful. Very soon, you see how they are used. We have the less than, we have the less than or equal to, we have the greater than, we have the greater than or equal to, then we have equal to, that is the same as what the comparison. Then we have not equal to, so this is less than or equal to, greater than or equal to, equal to, and then not equal to. Now let's come to assignment operator. Which one? We have the two types of equal to, the double equal to, and then the single equal to. Here we are going to differentiate them and know how each and every one work and where to use them and where not to. In programming, there is a distinction between setting one thing equal to the value of another and asking the question, is this thing equal to this? Is this thing equal to this other thing? What we are saying here is this. In programming, there is difference between assigning a value to a variable and then comparing two things and find out if they are equal. Now, when we assign the value of one variable to something else, in short, when we assign a value to a variable, example, variable name is equal to what? Rashid. So Rashid should be kept in a what? In a variable name, right? If we want to assign a variable name, assign a value to a variable, we use the symbol, the single equal to this one. So we say name is equal to, so we say name, first name is equal to, then the whatever we assign it to becomes the value. First name is equal to Rashid. So first name is the name of the variable, Rashid is the value. So we are assigning what? Rashid to what? First name. So we use the single equal to, we say first name equal to Rashid. So we are assigning Rashid to the variable first name. So that is that. So when we assign the value of one variable to something else, we use the equal sign, this one. In this case, the equal sign is used as an what? Assignment operator. If it is used to assign a value to a variable, then at that moment it becomes what? An assignment operator. So the single one is used there. So the single one is called assignment operator. We use it to assign a value to a variable. Now let's look at the comparison operator. Sorry, let me check something. Okay. The comparison operator, when we compare the value of one thing with another, we mean is the value of that thing or is the value of the thing on the left side the same as the value of the other one on the right side. Maybe we want to compare a number here and a number, and then we have the two equal to in between them. If we want to compare whether the two of them are the same, we want to compare and make sure they are the same, we use the two equal signs, which we call the comparison operator. If username equal this, then do that. Else, do this. So that is that. Just a typical example. It maybe there is a situation where we have a simple login form. Are you getting it? Simple login form. So, and the username is what? So you are asked to create a username and then the password. If your username is maybe KingTech, and then the password is what? Maybe KingTech 123. In the database of the system you are logging in, it will capture your what? Username as KingTech, and then capture your password as KingTech 123. So, and decision is going to be made there. So the program will say something like, if the username you've entered equal to the one, if you are coming to log in at another time, if you are coming to log in, and you enter what? KingTech, it will take that KingTech and compare it to the one you've registered with. So in that comparison, the two equal sign is used in that situation. So it's used to compare the one you used to register your account and the one you are using to log in. If there is different, they tell you what? Invalid what? Login details, right? So it means you will not be able to what? Log in. It means there is difference. And then it will do the same thing and compare the password you used to register and the one you are using to log in. So in that case, the password and then the username should be the same as the one you used to register before you can log in successfully. If you forget of one of them and you try using any other, it won't work because the two equal sign is used there to what? Compare the one you used to register and then the one you used to what? And the one you are using to log in. So basically, we use the two equal sign to what? Compare two things and make sure that they are the same. So that is that. So where we compare, where the two equal sign is used, it becomes what? The comparison operator. So basically, that is that. Now let's look at the example 1 here. So let's check something here. I would like you to pause this video on the screen and then you try. I'll help you with the A, B, and C. Then you do the D, E, and F. Let's check. So let first number equal to 3. So the first number is equal to what? 3. So we are assigning this 3 to the first number variable. Second number equal to -1. We are assigning -1 to what? The second number variable. Third number equal to what? 3. We are assigning 3 to what? The variable third number. And the fourth number is equal to 26. We are assigning 26 to the what? Variable fourth number. So basically now, then let's decide now. Then which of the following expressions are true? First number is not equal to second number. Is it true or false? If it is true, tell me it's true. If it is false, tell me it's false. First number is not equal to second number. What are we talking about? Now let's check the first number. The first number is what? 3. The second number is what? -1. So this is true because the first number is actually not equal to second number. 3 is not equal to -3. So here is true. Let's come to the B. Third number is equal to what? First number. What we are saying is that third number is the same as what? First number. Let's confirm that. The third number is what? The third number is what? 3. Right? The third number is 3. And then the first number is what? Also 3. So it means this statement is also what? True. The third number is equal to what? First number. They are the same. They are 3, 3. So they are the same. So this is true. Now C. Fourth number is greater or equal to first number. The fourth number is greater or equal to first number. How true is that? Let's check the fourth number. The fourth number is 26. And then the first number is what? 3. It's not true. This is false because the fourth number is natural, is greater. It's not equal to the first number. So it's just greater than the first number. So this is what? False. Now check this one, and tell me whether they are true or false. After that, you can proceed and check your answers. So there we go with the solution. We have true, and then we have true here, and then true, false, and we have true, and false as well. So you can check. Let's check the second number here, the D. So the second number is less than first number. How true is that? Second number is -1. First number is 3. Yes, -1 is less than what? First number, so it's true. The E. Please, sorry, a minute. Thank you. Let's check the E. The second number is less than what? Fourth number. So we are saying it's true. Let's confirm that. What is the second number? Second number is -1. And the fourth number is what? 26. Yes. Second number is less than what? Fourth number. Actually, -1 is less than 26. So it's true. So third number is less than or equal to first number. It's false. Let's confirm that. Third number. What is the third number? Third number is 3. And then the first number is what? 3. It's just equal to it. It's not less than or equal to it. It's not less than it. It's just equal to it. So for that matter, since 3 is equal to 3, we say it's false. So basically that is that. You can just go through it very well and then understand it perfectly, then you proceed. Now let's come to logical operators. Where we have logical operators are used to create compound conditions from given simple conditions. In a situation where we have a lot of conditions to make, we can use this or and and not operator to screw them together just to make our codes very simple, tidy, and straightforward. In the program segment with the or operator, the compound condition is true if either of the simple condition is true. If it is false if and only if both conditions are false. Now, in a situation or in a compound segment where we use the or operator, if you are comparing two things using the or operator, one of the condition must be true. If one of them is true and the other one is false, we can proceed. So that is that. Let's assume we want to we'll be seeing a typical example. So let's proceed and see the example. But when we use the AND operator, what it means is that both conditions must be true. AND means this and that must be true. If one of them is false, you can't proceed. If the two of them is false, you can't proceed. Both of them must be true. But with the OR operator, if you're comparing two things with the OR operator, one of them should be true. One of them must be true. If the two of them is false, you can't. If one of them is true, you proceed. Let's look at the examples. So we have the logical operator or here. So you can save time and space. That's what I just talked about. You can save time and space by joining two if statements with the or operator. So the following program segment, each displays the message okay if the number input is either less than 5 or greater than 10. Now this code here is the same as what is here. But let's look at how the OR operator has been used to simplify it here to get it what? 1, 2, 3, 4 line of code instead of 1, 2, 3, 4, 5, 6, 7. So instead of 7, with this OR operator, we have just 4 line of code. So you can see how powerful they can be. The input number and then the user inputs a number. So we are going to make a decision here. If a number is less than 5, write okay and end if. So you write okay and end. If number is greater than 10, you write okay. Now let's check here. So instead of you checking this by saying if the number is less than 5, then okay. Then after that you end if. Then you come to this one. Then you write okay. Then you end if. Let's see how it has been summarized here. After the user inputs a number, you take the number and then you take these two conditions here. Number, if the number is greater, so it's less than 5, then you put them into bracket. Or if the number is what greater than 10, then you put that one into bracket. Then, so you can see that we use the or to join this and that. So that is how powerful the or operator can be. So since the block of code that will be executed for both is the same, we can only do that if the block of code that will be executed after both is the same. So after both, we have to write okay. So for that matter, we can compare them. We can use the or operator to join them. We say if number is less than 5, which is here, write okay. So it will check that. Or and come and check here. Number is what? Greater than 10. So whether this one it should write okay or this one it should write okay. So we use or for that. So it makes it very simple and then tidy. Let's proceed. Now let's talk of the logical or operator example again. So a simple program in pseudocode to check if an employee is qualified for a loan or not based on their affordability and age. This is a simple program we're going to write. Let's assume you are a programmer and then the financial institution comes to employ you that they would like to get a simple app that the user can use to check what their affordability or their they can use to check their status as to whether they are qualified for a loan or not based on their age and then their affordability. You need a simple app. How do you create that app? Pause the video here, try writing it in pseudocode, and let's see how it goes. So after that, you can confirm your answer on the next slide. So let's check. I'm sure you are done by now. This is a solution. So a simple program in pseudocode to check if an employee is qualified for a loan or not based on their affordability and age. So here we're going to use the OR operator and you see the magic of OR operator here. So let's see. Start. Declare age as string. Oh, age as string. You can see that I'm wrong here. The age is not going to be a string but rather an integer. So we check that, please. Let's check this. Age is not a string. And you know what? Because it's a number. So a number can either be a float or integer. If it has decimals, we declare it as a float. If it is a whole number, we declare it as what? Integer. And age is a whole number, right? So we declare it as what? Integer. So sorry for that. Please forgive me. Pardon me for this. Typo error. I'm so sorry for this. So sorry. Thanks. Now, we are declaring age as what? An integer. So then declare net salary as what? Float. So we're going to use the net salary and then the age to what? Make decision. So after that we prompt the user, right? Enter age, then the user input the age, then we input the age. Then we prompt the user, enter net salary, then the user enters their net salary, and then we input the net salary. Now we want to make decision. If net salary is greater or equal to what? 800 cedis. It means your net salary, if it's above 800 cedis, if it is equal to or more than 800 cedis, or your age is what? Greater or equal to 18, then display you have qualified for a loan. Else means if this condition here is not met. If this is false, which means if your net salary is less than 800, and this is also false, which means if you are less than 18 years, then it means it should display and tell you that you are not qualified for a loan. So that is how the program works. So you can see that we use the OR operator to join these two conditions. If there were not to be OR operator, I would have written one if statement. If net salary is greater or equal to 800, then if age is, so you see that we just use the or to just join the two. So that is the powerful nature of what the or operator. So in this situation, if this is true and this is false, you are still qualified for a loan, because we talk of the or operator. Only one of the conditions must be true. If both are true, so you are qualified. If one of them is true, you are qualified too. If both are false, you are not qualified. Now, how will one of them be true and then the other one will be false? If your net salary is less than 800 cedis, it means this statement is false. But at that moment, if you are 18 years, so this program, one way or the other, it doesn't make logic, right? So we are saying something that although your net salary, which is the key to your loan, is less than the amount needed for you to be granted a loan. It's not up to the expectation, but based on your age, you should be considered, right? So that is how the program is. So either the age or this. If you meet any of these requirements, you are good to go. If you meet both, you are good to go. But if both are false here means if your net salary is less than 800, you are less than 18 years, it means both statement or the conditions are false. So for that matter, you are disqualified for a loan. So that is that. Let's look at the logical AND operator. So the AND operator also creates a compound condition from two simple ones. Just like the AND, the OR is also, just like the OR, the AND does the same thing. We can use it to join two different statements and then compare the conditions. If they are met, then we know the line of code to be executed and then the one to be skipped. Now with the AND operator, the two conditions must. The must is bold, underlined, and we are stressing on it. The two conditions must be true for you to proceed. Let's look at the example. Now, we are writing the same program, and then we are using the AND operator to make decision here. So let's check. There's a simple program in pseudocode to check if an employee is qualified for a loan or not based on the affordability and age. So we start a program, declare age as integer, please, not string. Correct it for me, I beg you. And then we declare net salary as what? As float. Since money, there can be some floating point numbers there. So we declare as a float. Now, right, enter age. So the user enters age, then we input age. The user enters salary, then we input net salary. Now we make decision. If net salary is greater or equal to 800, it means if your net salary is above 800 cedis, is equal to 800 or more than 800 Ghana cedis, and your age is equal to or greater than what? 18 years, then you are what? Qualified for a loan. So it will display and tell you that you have qualified for a loan. But if this is less than what? 800, and whether you are 100 years here, it means so far as this one is false, you are not qualified for a loan. If you like, get 10,000 Ghana cedis here, which we know is what? Greater than even your requirement, which is 800. Provided you are not 18 years, which means here is false, you are not granted for a loan. Before you can be granted for a loan, these two conditions is a must. They must be true before you can be. Since the AND operator is used here, the two conditions must be true before you can get a loan. If one of them is false, displays and tell you are not qualified for it. If the two of them is false, you can't even talk about that one. It displays and tells you are not qualified for a loan. That is that. The logical NOT operator, unlike the OR and then the AND, act upon a single given condition. With the OR operator, that one, it just negates or changes what do you call it? The statements to the opposite. For example, male. When I put male, so for example, male means male, right? But if I put not, if I bring not into bracket male, it means you are a female. I've just negated. You are no more a male, but rather a female. If I am female and then I put not, and then into bracket female, it means you are a male. So that is how this one works. So we'll see how we're going to use it when we begin writing our Python code. Now try the following. For the following pseudocode, if number is greater than 0, then write yes, and if there. If number equals 0, then write no, and if. If number less than 0, then write no, and if. Now, how do we simplify this? Say, write a single if-else structure that has the same effect as the given code. It means we should summarize this code, but I shouldn't change anything. We should summarize it, but I shouldn't change anything. And then after that, we create a flowchart for it. You can pause a video here and try that. Now, since this one, the block of code that will be executed here and here is no, so that we can combine this one using some magic operator. And do you know the operator? Since they say if the number the user enters is what equals 0 or is less than what 0, it should display no for both. If it's equals 0, display no. If it's less than 0, display. Why don't you say if it's equal to or less than, then we just display no for once, so that we just summarize here. Let's check that. Solution. In pseudocode, start. Declare number as integer. Right, enter number, input number. If number is less than or equal to 0, and you know that the previous screen here, we were told that if it's equal to 0, it should display no, right? If it is less than, also we display no. So we went there and then we came here and we said, if the number is what less than or equal, so we just combine the two line of code there, the two conditions there, we combine them using the less than equal to. The number is less than or equal to 0, then display no. Else means is what is greater than 0. So we display what? Yes, and then we end if the program. So that is that. Let's see how the flowchart looks like. So flowchart, this is the solution for the flowchart. So start here. Declare number as integer. You do that. You input number. We make decision here. Is the number less than or equal to 0? If yes, write no as we saw. If no, then write yes. So you end the program here. To after writing no, you end the program. So this is the flowchart to this pseudocode. So you can check them and then confirm them very well. Now we come to another statement we call the nested if statement. Nested if statement. We also have another we call the we'll be looking at that. I don't want to even go there. That is when we have one if statement in another if statement. We call it nested if statement. I repeat, if we have one if statement in another if statement, we call it nested if statement. When one structure is nested in another, this means the entire inner structure occurs within another structure. When one if statement is placed into another one, it becomes what? Nested if statement. Now let's see how the syntax looks like. So the syntax for nested if statement. So if test condition 1, then do this. If test condition 2, then do this. So you see that after this, it's not terminated. There is nothing like end if here. But we went ahead and added another if statement. So we have nested one if statement into another, and then we bring the end if here after these two conditions are met, and then the statement are executed. Let's look at a typical example here. Example, determine a student had an A, B, or D. This is like a grading system program, right? Written in pseudocode. So start. Declare variable score as what? Integer. So display. So enter the score. You tell the user to enter the score. The user enters the score here. If score is greater or equal to 80, if you score 80 and above, or your score is what? Less than or equal to 100, or 100 to 80, down to 80, we have captured here and captured here. So it's ranging between 80 to 100. Then we came and then added another if statement here. So we have nested one if into another if statement, because there is no end if after, and there is no any block of code here to be executed. But we decided to bring another what? If statement here, which means we've nested one if statement into another. So we check here again and say if score is greater or equal to 80, then display A. So if these two conditions here are met, one if statement nested into another if, then we display A and say the student scores A. Else if score is what? Less than or equal to 60, which means below 60, from 60 downwards, display B, then end if. Else, whatever the user enters aside this, display what? D. And then you end the program. So that is how this program also works here. So we have one if into another if. It's done. When we get into Python, you see how it works magically. So that is that. Now let's come to our assignment for the day. As a computer programmer, I would like you to think very well and then tackle this program with ease without any stress. As a computer programmer, a principal of a famous private school in your community, or sorry, in your country, has a challenge in his school. When it comes to people from all walks of life checking the entry requirement for admission into the school. As a computer programmer, write a simple application in pseudocode that will enable people from other parts of the world to use in checking the entry requirements for admission into the school. Now, the entry requirement here is as follows. The students must be a Ghanaian, must be 18 years and above, must be a male or female. So any of these two. Are you getting it? So write a simple application for checking this entry requirement. What it means is that you should take 3 inputs there. Let me give you a clue. We are taking 3 inputs. Should I give you a clue? Please think and then do it by yourself. Think. Go through the previous assignments, previous what do you call it? Lessons, especially this particular lesson. Go over it again and then tackle this problem with ease. It's not a big deal at all. It's very simple. It's similar to one of those programs inside there. So you can check that and then you figure that out. So in summary, we talk of can I quite remember? Yes. We talk of a single alternative type of program, which is in sequence. So we talk of sequential type of program, right? Where programs are written in sequence. Do this, do that, do this, do that, and then you end the program. No decision making somewhere. And we talk of this decision and selection, where at a point in time you have to stop and make decision, right? So that type is called the decision and selection type of program. And we also talk of logical operators, where we have the or, not, and end, and we talk of how they are used. So you go through that as well. And we also talk of the comparison and assignment operator. We talk of the less than and equal to, less than or equal to, not equal to, and all that. We talk about all those things. Please go over it again and try very well to understand it before. And in fact, the moment you understand this and we start writing Python, it becomes simple and easy and straightforward. So I advise you to go over the lesson again and try to figure out things that may be bothering you at a point in time. Try to understand them very well. Then you come and challenge this particular problem here and make sure you, in fact, you disintegrate it, you solve it, you kill it for me. I'll be very happy. I will be very happy. Thank you very much for watching. This brings us to the end of this lesson. So thank you so much for watching. And I pray that all what we've learned should be in our head so that at the point in time when we need them, we can be able to retrieve them and use them effectively. So till our next lesson, lesson 6. So thank you very much for watching. Stay blessed. Bye for now.